All right, today on Free Field Training, we were talking with Chris about ice diving. So we recently did a class where I got to come in video. We're going to be putting that in as we go along here so you guys can see what it is we're talking about. Chris, what was the class about, and what's the end goal for the class?
So the class that we ran was an ice diving class, and we were running it with public safety divers. So that was their introduction to ice diving. So that's the point where they start, where they will then go and do some more advanced training on ice rescue training.
So is it, who's going and taking this class, this particular ice diving class?
This one this one was explicitly for fire departments, but we've also had police departments come through the class. So anybody that's considered a public safety diver, this class was specifically geared towards them.
All right, and what's the company that runs this?
So the name of the company is DJ's Scuba Locker. They are the company that runs the training. The certifying organization is a group of organizations called TDI, SDI, ERDI, and they're a scuba certifying organization. And the branch of them that does the public safety specifically is ERDI.
All right, so we want to thank DJs. I'm going to put links for their information down below if you guys are interested in knowing more about the classes and their address and phone numbers and stuff. It was very nice of them to invite me to come out and video the class, which Chris was an instructor and one of the safety divers for. All right, so what's the end goal of the class is to get them to the point where they can rescue people from under ice?
Correct.
Is the idea?
Yes.
Okay, and what's the timeline on rescuing people from under ice?
So it's very interesting the way the human body responds to cold water. There's a lot of ongoing research with how long people can actually be submerged and still live. A lot of free divers can do in excess of 20 to 30 minutes fairly regularly, and it's been known for people to be submerged for 45 minutes plus and still come out after treatment relatively unscathed.
I never would have thought it was that long. That's actually kind of shocking to me that it would be 45 minutes. Because when I saw you guys getting dressed, like they've got layers and layers of stuff, and we're going to get to some of the gear that they use and some of the specialist gear that they're using for it in a minute. But like I saw you guys getting dressed, and I was like, well, I would anticipate being dead by now. And he's like, no, if we don't put all this stuff on, we'll be dead as soon as we get in that water. So, all right. So what's some of the what's the process? So we'll talk about the gear first because I got to sit there and tape while you guys were gearing up with all this stuff. So what's the process of getting ready to go under the ice to try to get somebody else?
So once you get the call, right, obviously time is of concern. This being a training dive and an introductory dive, we spent a little bit more time focusing on how to make sure that we gear up, because slow is smooth and smooth is fast. So you want to be able to know the process intimately before you try to do it at speed. But the way that it works is once you've trained, everybody knows their role. And people that have done a lot of group training know how important knowing your role is. So once you get there, somebody has to create access, right? Somebody has to cut a hole in the ice for the divers to be able to get in. Somebody has to be tending to the divers because it's a lot of gear, and particularly with public safety diving, there's the added equipment of communication and some of the dry suits and the way that they utilize their different breathing systems require a tender to help get set up. And then there's the diver themselves who will actually start gearing up in the ambulance on the way over.
All right, so it'd be fair to say that in an actual incident, this would be like a task force operation. People would show up, and there'd be people whose only job was, all right, well, I'm going to go prepare the area that we have to go under, and you're going to have like 5 people helping one person put all their stuff on.
Correct. When they activate, often when dive teams are activated, the way that it works is there are very few public safety organizations that sponsor full-time dive teams, particularly in the Midwest. So when they get an activation, a lot of times they'll activate members from different departments who have all trained together, and they will respond to that as such.
So what's some of the specialized equipment? If people are coming onto a video about ice diving and rescuing people under the ice, obviously they probably have some background in understanding how scuba works. But what's some of the differences between the equipment that you're using for ice diving, trying to rescue somebody from under the ice, than a person that took their scuba class to go dive by the reef on vacation?
So the two major pieces of equipment that are going to be different are your thermal protection. When you're doing ice diving, particularly in an operation where you don't necessarily know how long you're going to be submerged, we utilize what's called a dry suit, which means that at a minimum there's seals around the wrists, neck, and feet if they don't include dry boots, where water is actually not penetrating the suit, and you actually utilize, they call it underwear, but it's like a fleece material, and that fleece material creates a layer of air that helps insulate you and keeps you completely dry, and that keeps you warmer than if you were to be utilizing a wetsuit. And if you don't know the way a wetsuit works, is a wetsuit is a layer of neoprene, which is kind of a rubbery material. And the way that the wetsuit is designed to work is you actually let water into the wetsuit. The wetsuit then keeps that water close to your body. Your body heats the water, and that water, and the wetsuit keeps the water next to you, so you're staying warm. This is completely different, right? The water temperature can actually drop below freezing. When we were out there, the water temperature was about 36 degrees, but it can actually drop below 32. So we utilize dry suits for safety, right, to stay warm. The second piece of equipment that's pretty vastly different than what recreational scuba divers are used to using. These are sometimes used in recreational scuba diving, but I haven't seen them very often. This is what's called a full face mask. And what this does is this covers almost your entire face. And part of the reason that public safety agencies use these is you can include what they call comms, which are communication devices. And you can tell this one is set up for communications with the two speakers aligned with the ears, and then the cable that'll plug into the comm system. And we can talk about that more in a little bit.
So we actually have a question. We're live streaming this on Instagram. If you guys want to be part of the conversation with videos like this, follow me over on Instagram. There's going to be a link down below. Somebody asked, is there the type of tanks that you use for this type of work, is that significantly different than what they would be familiar with if they were doing recreational diving, or is it the same like air tanks?
So in the Midwest in the United States, people are typically using aluminum 80s, and when you're doing ice diving or any type of overhead environment, you always want to have a spare air source. So it'll look like two regulators on the back. You want everything to be a complete backup. So to answer your question, some departments use the aluminum 80s with like an aluminum 40 as a spare. Other departments are going to a system that's called Interspiro, which is more of a surface supplied air system. So depending on which department and which team you work for, there's two different options. But even with the surface supplied system, you always want to have a backup.
So you mentioned that the surface supply system, so like an airline going down to the people that are under there?
Yes.
I noticed when we were out there that your comm system, your radio, basically like radio, was run through a wire, like a tether. So you've got one guy standing on the surface who's got a headset on that's talking, and they're communicating through a wire down to the people down below. Why is it like that instead of some sort of wireless system?
So radio waves just don't travel well underwater, and it's just kind of as simple as that. Like you can't use GPS underwater, you can't use regular radio systems underwater because the water absorbs that fairly quickly and you get no type of range on that. So all of the distance communication that happens underwater is done through lines. And that's actually what this sticking out of the mask is for. This plugs in to the tether line, which is normally different colors. So when you're ice diving, you'll typically have 3 divers ready to go. You'll have a buddy pair that's in the water, and then you'll have a safety diver on standby. One of the common ways of separating the divers is by different colored tether lines. So you can have red diver, blue diver, green diver, and you'll know who they're talking about based on the tether line.
Right. So, and is there any other equipment that, like right off the top of your head, is like significantly different from what people would be used to?
So as far as the actual scuba diving portion, those are the two big things, but there's a lot of other things that go into it as far as prep and actually being able to cut in. So a lot of the departments in the Midwest use a tool called the mother of all saws, which you'll see on the video. It's basically just a big saw that you can use to cut through the ice. Another option is people will actually use a chainsaw that they convert to marine usage with marine oil. So you use those to be able to cut a hole in the ice, and there's actually a lot of rope involved. So you need rope to tie off as tethers for the divers because it's an overhead environment. You need rope to tie off to when you cut a hole in the ice to enter, because there's 3 divers, we'll typically cut a triangle. And you also need to tether into the ice that you're cutting to be able to pull it back up when you're done. And you also need ice hooks, they call them, to have a solid tether point for the divers. So you're tethered several times. You're tethered to a solid anchor point, and then you have an actual tender. And then when you tie off on your equipment, one of the requirements for underwater ice diving for BCDs, which are buoyancy control devices, which are the jackets that scuba divers wear, you have to have stainless steel solid D-rings, so they have to be welded shut, or you have to have a completely separate rated harness for it to be able to tie into. And the reason for that is if you're ever doing anything in a current, or if you ever get tangled and somebody is pulling on the line, they don't want that to be able to separate, which is why it has to be a solid D-ring.
You know, that's something interesting. We were doing this on basically a lake, and I didn't even think to ask the other guys that were there, what else goes into this if it's a river?
So that's...
How much more complicated does this get if there's water flowing underneath this ice?
So water flowing will always complicate things immensely. Part of the issue with water flowing is knowing where to even start to look. So that's part of the issue there. And the other issue is that with flowing water, you don't necessarily know that the ice is a uniform thickness. Because when you get into rivers and wider bodies of water, sometimes there'll be a current in the middle, and that current will cause the ice to be less thick than it is kind of at the edges. So when you start to talk about moving water, things get significantly more complicated.
Right, so ideally we're talking about on a lake, someone's fallen through ice, or a vehicle's fallen through ice, and if somebody's ended up underneath the ice, we got 5 people on them, gear them up, get 3 people ready. Another team has cut, a triangle in the ice to be able to put people in. You've got people working just comms that have connected everything together. You got people sitting, in your triangle in the ice waiting to go. What's the process of actually going down there and getting somebody out?
So what will normally happen is, depending on whether or not we know where the entry was, so one of the more common scenarios for this type of rescue is when somebody will take a snowmobile late in the season out onto some ice, and they'll end up going through. So if we know where that was, we can start the search there. That makes things a little bit easier. And then what will happen is we do what are called spiral searches. So you let out a little bit of line, and you'll do basically a 360. You let out a little bit more line, you do another 360, and you keep expanding out until you find what you're looking for.
Now, I noticed when you guys were doing it, they were shoveling like reference points out from where your entry was in the water. What is the shoveling for?
So the shoveling is for the divers in case that's like a backup safety system. So in case they lose a tether, you can actually look up, and as you're looking up, where the snow is removed, you can actually see more light. So what they'll do is, spiraling out from our triangle entry point where we need to be able to get in and out, they'll actually put spokes like a wheel, and sometimes you'll add and make little arrows so it points back to where the entry exit point was. Because again, we're in an overhead environment, so even though we have scuba or the surface applied, that doesn't necessarily last forever. So if we get separated from the tether, we need a backup to know how to get back to the exit point.
Assuming it's daylight when all this is happening.
Even when it's night, when depending on how much snow there is, you can also see a difference depending on how much ambient light there is. But yes, it's much easier in the day.
As all things public safety, that rarely happen during the day, just like house fires. They always seem to happen at night, generally when it's raining, but not raining enough to help, just enough to cause a problem. All right, so we get out and you do a search of the area, like within your tether zone. And what happens once if you find somebody, how do they get them out?
So the rescue is basically, depending on what the scenario is, obviously the quicker you can get them to the hospital, the better, right? So you can say on comms, because a lot of times, like everything public safety, if there's one, there's two, because you don't always necessarily know how many.
Yeah, if a snowmobile going in,
Right.
the chances somebody's going to be sitting on the back of it are pretty good, yeah.
Right. So you don't necessarily know how many, but you always want to handle what you got in front of you, right? So you can say on the comms, found one. They'll actually pull you in with that person, right? You actually, as the diver, are not going to be providing the care. You're going to get them out as soon as possible, and then depending on what you know about the situation, you can either go back out and continue to search, or if the information is good and confirmed that there was only one person, then you start packing up.
Yeah, so when I saw you guys coming out of the water, it didn't look like you were in condition to do anything after 20 minutes in freezing water at all, other than get all that stuff off and then sit in a truck with the heat blasting until you got warm again. All right, is there anything else you want to go over before we go to questions on here and see if we have any pertinent questions to the conversation?
No, I think that about covers it.